To the chairs, please, so that we can start the final session of this fourth ORF Kalpana Annual Space Policy Dialogue. Dear Dr. Saraswat and friends, dignitaries and friends, happy to welcome you back to the final session of the ORF Kalpana Dialogue. It's been intense 3 days of discussion on very pertinent contemporary space policy issues. In the last 4 years, this platform has developed and matured to have the ability to bring together several different stakeholders, from industry to scientific to policy, military, and global institutions. We got off to a very good start, to sum up, Dr. Saraswat, by having 2 days ago with two fascinating addresses. The inaugural address done by Lieutenant General Amit Sharma, former SFC commander, and special address by Mr. Sunil Gupta, Secretary, Telecom Regulatory Authority of India. Thereafter, we had a brilliant dinner panel looking at the satellites and telecommunications. And since then, over the next 2 days, we have had a number of pertinent themes, including space security, space stability and sustainability, emerging space actors, emergence of private sector included, and the commercialization of space activities, multilateral governance architecture, legal issues and militarization of space, changing space environment, and the last but not the least, we had the look at the technology, propulsion technology, and the Indian space industry scenario. To give you a summary of discussions, on the first day of the dinner panel, we discussed space and telecommunications. In the broadband and broadcasting sectors, for instance, there are several policy issues that need urgent focused attention. The demand for direct TV broadcasting and satellite internet services is fast rising in India. In addition, the central and state governments of India are also increasingly seeking satellite services in planning and execution of various developmental initiatives. But the available Indian transponder capacity falls short of this demand, and the process of adopted for leasing capacity from commercial satellites remain cumbersome. The current policy is also ambiguous with respect to transparency in contractual terms, and at times it takes anywhere between 3 to 9 months for gaining regulatory approvals. Therefore, immediate policy attention is required to clear these hurdles by adopting a streamlined transponder policy. Second, we moved on to the second day. We started with a session on space security, where we discuss growing counter space capabilities across the globe and challenges of radio frequency interference. There was a big focus on China, where we drew parallels between China and the US strategic space priorities. The complex interplay between civilian and military use and integrated warfare was also discussed. The presentation also highlighted the need for improving resilience, comprehensive response, and diplomacy. In the Indian context, there was also an emphasis to undertake organizational restructuring, building up capacity, and human resources. Thereafter, we went on to discuss space stability and sustainability. The increasing dependence on space resources warrants protection of space assets from a number of different threats. Panelists also provided a useful overview of fundamental issues affecting space sustainability. These also brought in subjects such as space situational awareness, space debris, and space weather. Collaborative mechanism is a way forward. That was the conclusion from the panel that came about in this particular. It was also pointed out that norms for outer space activities and stability does exist, but enforcement mechanism is lacking, and that's a key issue for everybody to look at. Thereafter, moving on to the emerging space sectors panel, we had 5 speakers from the emerging space nations who shared their perspectives from their own countries: Nigeria, Philippines, Brazil, Taiwan, and Portugal. The speakers detailed the origin and rationale for their space programs, which vary from based on their own national needs. Certain countries' disaster response and mitigation, development, promoting industry, roadmap and development strategies were identified. Moving on to the 5th panel for the day was the multilateral governance architecture, where the panelists agreed by and large that there is an existing outer space architecture, but that needs to be updated, that needs modifications at this point of time. But this is done to be done by building on the existing legal framework than reinventing the wheel in a sense. But however, the change in the nature of space activities and growth of space actors mean that existing mechanisms need urgent modifications, and the political difficulties at this point of time have come as a big hindrance among the space actors in devising new measures. Last night we had an ORF ICRC sponsored dinner panel, which focused on militarization of space and legal issues, wherein the panel described emerging threats to outer space assets in the, particularly looking at the 3 nations that have demonstrated ASAT capability. The debates also focused on the application of international humanitarian law to outer space activities, as well as the utility to looking at existing international mechanisms to tackle the challenges of militarization of our outer space. Coming to the last day, we had sessions mostly focused on commercial and industry-related panels, where we started with small satellites, examining the prospects, challenges, and risks involved. Satellite industry has undergone a paradigm shift over the last decade, with small satellites becoming mainstream globally. The panel looked at the factors driving small satellite constellations globally, but also to see how cost-effective they are as compared to traditional assets. The panel went on to discuss the potential of private players in India to build and operate small satellites constellation and may even compete globally. The discussions also looked at the regulatory hurdles in launching and operating small satellites from India. Next, we moved on to a panel on changing space environment, where we had a mix of panelists from varied backgrounds, and they discussed as to how their specific industries contribute to the changing space environment and what they saw as the emerging regulatory, financial, and technological challenges. Finally, the last but one, we had the panel on India's space commercialization drive, looked at how the ISRO is undertaking steps to increase the available satellite capacity, launch frequency, and capabilities. The importance of hand-holding the industry to build satellites as well as launch vehicles, ultimately realizing a completely industry-built mission, was emphasized. These processes raise as many opportunities as doubts and challenges on the actual materialization of these capabilities. Entrepreneurs in this industry have developed many products and downstream applications that could be boosted in the domestic as well as international markets. Some of these questions, risks, and challenges were debated during this particular session. The last panel on propulsion technology and in the Indian space industry looked at enabling the private space industry to develop, buy, sell, transport, store, and export propellants and related materials. The panel also discussed the regulatory mechanisms for the same. So considering now the need for a continued debate and dialogue on some of these policy issues, we at ORF have been holding this dialogue on an annual basis. This is the 4th edition of the annual space policy dialogue that we are doing. I want to thank all the participants, and many of whom have come, you have stayed on for the full 3 days, despite the varied subjects that we have debated. At this point, I want to bring in our guest of honor, Dr. V.K. Saraswat, to deliver the valedictory address. Dr. V.K. Saraswat is currently a permanent member of NITI Aayog. He is an Indian scientist who served as Secretary, Department of Defense R&D, Director General of Defense Research and Development Organization, and Scientific Advisor to Raksha Mantri. Dr. Saraswat is the chief designer of missiles like Agni, Prithvi, Dhanush, and interceptors of ballistic missile defense program. For his service to the nation, he was conferred Padma Shri in 1998 and Padma Bhushan in 2003 from the Government of India. I now invite Dr. V.K. Saraswat to come and deliver us this valedictory address.
Thank you.
Thank you.
Very good evening. It's a pleasure to be here on the valedictory event of this 3-day seminar. 3 days? Oh, 3-day long seminar. And what I gather from what Rajeswari has just mentioned, I think you have touched upon each and every aspect of space technology, space policy, space applications, utilization, and where do we go as far as country is concerned with respect to the requirements. I thought I'll cover some of these aspects in my talk today, and maybe a bit of repetition may be happening You have to bear with that. But I'll try to give you a perspective of what we have done and where is the space technology moving to. And in the changing phase of the what we call as the new space age, which is emerging, where should the technology go and where should the policy framework define? Because today what is happening in the space sector today is quite different from what happened in the early 60s, 70s and 80s. And that demands a new application of laws, new application of policies, and also a real commercialization which is taking place in terms of participation of private sector in a big way, demands that regulatory mechanisms have to be far more deepening, and they should be in a position to control the kind of chaos which is likely to happen if we don't do that. So I'll just start with that new space age, a technology and a policy perspective. You all know what space is today. It is a congested, highly congested space today. Almost about 1,400 satellites, 22,000 10 centimeter debris, and more to come. The debris is becoming a major problem today. We have a big problem as far as the orbits are concerned. We have contest there. Orbits and radio frequency allocations are a problem. We have the operational environment, which is also degraded in many ways. And today it is no more bipolar. Once upon a time we used to have only Russia and America doing this, but it's no more bipolar. Multiple capabilities are concerned today, and there are increasing diversity of the public-private contribution which is taking place in the space segment. I was very happy to hear that countries like Nigeria and Philippines and all have participated in this conference. Obviously, it shows the expanse at which this whole process is taking place. The usage are regulated only to a certain extent. I think we have policies, but I think there is a lot to be done. And pervasive throughout the society, dependency and vulnerabilities are increasing. So there is a major change which is taking place as far as the space segment is concerned. That's why we are now talking of space as a new space. And the G7 Foreign Ministers Conference summed up very nicely in Hiroshima in April 2016. What they said was that the outer space activities have immense potential for social, economic, and the technological development of all. You don't want to display? Achha, you have come. Okay. We remain concerned about the development of anti-satellite capabilities. We are committed to enhancing the long-term safety, security, sustainability, and stability of the space environment, to increasing transparency in space activities, and to strengthen norms of responsible behavior. The word is very clear, the responsible behavior for all outer space activities. And I think if all of us follow this dictum, then we will certainly come up with policies which will be very much beneficial for the mankind in general. In India, we have done major galloping development as far as space is concerned, right from vast number of satellites, Earth observation satellites. Our latest has been Cartosat 2 and 3 series. Then we have communication and navigation satellites. In 17-18, we have a major program of IRNS 1H to GSAT 17. We are planning. We have space science and planetary issues, in which we have done Mars orbiter spacecraft. We have also done aerostats. We have also done now announced that April we are going to have Chandrayaan-2. So it's a major activity. And we have our workhorse launch vehicles, which are PSLV, GSLV Mark III, and the GSLV middle one, which has been there, and 30 to 40 launches. Almost today we are in a position to almost one launch a month. That kind of a frequency has been achieved. That means the country has really matured as far as the technology of satellite development, manufacture, as well as launching is concerned. And this is the total space scenario we have, which is aimed at harnessing the space technology for national development and pursuing space science research and planetary explorations, basically. And India has 42 operational satellites in space today, out of which 15 are communication, 14 are Earth observation, 4 are MAT satellites, and 7 are the navigation, and 2 are science satellites. Next, please. But if you look at the overall applications which have been identified with the space today are communication, the emergency services, the energy, financial services, then we have the food with respect to agriculture, then government requirements with respect to communication, and also e-governance, health, transport, water, defense is one of the major user of the space activities, civil nuclear activities, space and chemicals, all that. Obviously, this requires that the space security and resilience plan has to be developed, because if this is the spectrum which we are covering today, it cannot remain directed only to the scientific exploration, because applications are far too many. So we need to develop a very elaborate plan. Today, Indian Space Agency is responsible for all these sectors. Now, is it the right approach? However, for global space security, we need to have an amalgamation of military space and the civil space under one agency. We have to start looking at that kind of a format as far as the space in India is concerned. We have to start looking at that. Now, what are the various other things which are happening today? You are aware of that, that we have gone into the augmented satellite-based state navigation systems. The need for geospatial positioning and tracking is becoming more and more intense for civil sector, where navigation is becoming a requirement, both in terms of accuracy, both in terms of landing and takeoff of aircrafts, fleet management, variety of things, aviation, commercial navigation activities, all this. And ultimately, you will need, in the future trend is going to be a global coverage through multiple interoperable regional augmented satellites-based navigational systems. That is what is the requirement going to emerge, and large-scale commercialization will be the requirement. So this is one technology which is going to remain as a mainstay as far as the space utilization is concerned. Small satellite clusters replacing the large satellites. That is what I think you also debated in your discussion. Today, high throughput satellite market is fast growing, with multiple government and commercial satellites currently being launched. And this is resulting in high data rate satellite transmission capability, which in turn is creating opportunities for enhanced commercial and military broadcast services. This is benefits are very, because you get low cost, high throughput, you get location specific connectivity options, but it has got some immediate impact as far as the technology is concerned. For example, we have now the multi-beam, spot beam satellites which are emerging today. Dedicated shared gateway beams are also emerging. Large scale frequency reuse is also taking place. Closed open networks are becoming, so variety of technological changes which are taking place, and this will all happen in 2018 and beyond. And finally, it also gives you the high density television, ultra high density television broadcasting services, faster broadcast internet, and now you see what is going to happen is you have all your channelizers sitting on the satellites. So your internet will be moving from Earth, it is going to move on to the satellite. So this kind of a wideband broad-based internet access will get developed. So this is the major area which is going to be the focus in the coming years. Space tourism, you are already seeing what the Virgin Galactic is doing. You are already seeing what SpaceX is doing. The very unique commercial aerospace business model is evolving with the objective of providing suborbital human space flight service to civilian customers. This business, categorically titled Commercial Space Line, marks the birth of a new industry in the commercial aerospace domain. That is right from the scheduling of key progresses, what kind of regulators would be needed, what key challenges or restrictions, key technologies like reusable launch vehicles, reusable systems which will completely take it and come back kind of a system. And future drivers, of course, will be the economy. The viability is going to be the major focus as far as these systems are concerned. Then there will be space institutions for manned and unmanned human tourist orbital space flight. They will get developed. Small satellite clusters. Now, somebody may be talking purely that small satellite clusters may be only useful for the military applications. But I certainly feel that with the low manufacturing cost and not mandating dedicated launch vehicles, small satellite clusters are beginning to set the trend for realization of improved space capabilities, also enabling penetration into densely populated orbital space. So we have what we call as the formation flying and navigation and formation control, modularity and open architecture for expansion of existing clusters, how they are going to move, inter-satellite connectivity, reconfigurable onboard electronics, and small satellite launch capabilities. All this will become part of the major system which is going to come. By 2030, we will see about small satellite clusters delivering complex, higher capability multi-missions at a very low cost. That is the kind of a scale at which the small satellite business is emerging today. Certainly, it has advantages like reduced financial risk, it has improved capabilities, It has multi-mission satellites which can be launched. In the same cluster, you can have many other activities which can be done simultaneously. And so increasing adaptation is going to take place. Now, there's no doubt that small satellites are going to stay. In fact, some people are making statements. Gone are the days of mammoth large satellites. It is going to be the era of only small satellites. I think we have to get ready for that. Satellites in commercial aviation. Just now I was talking to Colonel Singh when he was from, where is he? I think he's somewhere here. He was talking whether it can be used for the infantry. I said, why can't? It can be used for each and everything. There's an increasing need for satellite connectivity in commercial aviation owing to the operational need for seamless connectivity today. Both from voice communication, now we are going to have internet services on board. We are all going to have TV services, internet service, everything on board. Wi-Fi, the mobile connectivity, all that will be available today. And flights will be automated flight operations. All commercial aircrafts will be connected via satellites. Obviously, this needs a large satellites in the commercial aviation sector, which will happen. So this is another area which will demand more and more satellites by about 2030. The manufacturing process for the satellites and satellite bases components and devices is also undergoing a tremendous change. It is no more the same conventional methods. Today we have 3D printing in a space application in a big way. It has cost impact, it has quality impact, it has turnaround time impact in a big way. 3D printing replacing conventional manufacturing practices, which will have right from 2014 to 2030, it will certainly take it from the initial laser printing to right from polymers to metal to all kinds of components which can be done. That will result in faster realization of the satellites and other components. So this is another area which is going to find application here. So certainly the space tourism will not happen unless we have reusable launch vehicles for cost-efficient space logistics. It has gained prominence and the industry is looking to realize partial and complete reusability to launch vehicles. The current focus is on the reusability of the rocket boosters. We have seen the boosters are being retrieved. The cost of refurbishment and operational reliability will determine the economic viability of the system. Now, some people are finding it very difficult. Even our own Department of Space are able to recover some of the systems now. It is feasible today. So driving requirements are cost effectiveness, standardization of the launch operations, all that. And current focus is whether we can have all the stages recovered. So opportunities are we can take COTS components, we can have commercial orbital transportational services by doing this. Cost targets are payloads up to about 1800 kg, 5 million per launch, $5 million, and payloads up to about 45 kg, $1 million per launch. In fact, Dr. Kalam used to say that if you have to really do space solar power, which is a large payload which is going to be put in the orbit, the cost of launching satellites has to come down from about $40,000 per kg to something like $200 to $300 per kg. Then not only it will become affordable. Now, certainly reusable launch vehicle comes in this segment, and we need to really look at this as a technology option. Propulsion, you had dialogue on propulsion, I understand. Now, all electric propulsion systems for satellite are finding the demand for longer mission time and reliable station keeping capability are, can you go to the next slide, please? Yeah. Capability, overcoming technical gaps such as the low thrust and subsequent orbit transfer time delays along with industry's ability to commercialize the technology essential for wider adoption is what is coming. It is more than 10 times efficient as efficiency gain, about 1/10 in mass, and about 50 to 70% higher as far as the lifespan is concerned. And it also gives you higher return on investment. So these are some of the positives as far as the electric propulsion is concerned. But there are issues with respect to single point failure. There are other scenarios that low thrust, it cannot develop very high thrust, and orbit transfer time delays could be more because of the time constants of the control system, what they will follow. So obviously there is a technology demand of higher thrust, additional payloads, miniaturization, and commercialization of the technology critical if we are looking for deep space exploration using the electric propulsion. We need to do a lot of work in that direction. Commercial satellite imagery-based services, all of you are aware of that. Today there are images providers are available, images are available from different service providers to others, and one country to another country. Image resellers are available, image analytics are available. So this has become a big business today as far as the space-based images are concerned. And on demand, on real time, you can get data, and responsive decision making can be done based upon that. And new products are emerging in this direction. But again, here also the cost is a very, very important driving factor. So this is very important area as far as the images are concerned. Next please. Other things are robotic servicing technologies for space application. This is one area which is needed for extended satellite mission lives have created a need for in-orbit repair. That means the satellites can be repaired in orbit, or refueling can be done, which are currently evolving. These technologies will bring dead satellites into operation through repair and refueling missions. These are also expected to help remove dead satellites from orbit to create sustainable space real estate. That is going to be, so driving needs are long satellite missions and established in-orbiting servicing, refueling, increased focus on space debris, and small satellite missions for in-orbit inspection and things like that. They are all can be carried out if we get. For this, robotic becomes a major, major technology which needs to be developed. Future is dedicated in-orbit servicing and satellite missions, sustainable space real estate, and prolonged satellite missions. That is what will help, and robotic will become a major thing. You also discussed in your panel discussion small satellites, and small satellites are a major thing that is happening today. There's an advantage because it can give you access to very, very variety of applications. Flexibility is the order of the day. Unknown possibilities, wealth of new ideas can come. I have seen students from various engineering colleges and universities coming up with different ideas as far as satellites are concerned. Allows entry of new space actors, certainly it is a good idea. Lower barriers to entry, addresses technology gaps between developed and the developing nations, facilitates capacity building. You will find that what used to be only the realm of Department of Space in India, where only Space Application Center or ISAC or something, there are engineers with there. Today I see IITs, NITs, Delhi University, variety of people coming up with this kind of a. So there is a tremendous advantage of small satellite activity, education and training per se, it becoming, and these are the guys who will ultimately take the larger future missions. So that is the biggest advantage. Broader collaboration is possible in this case. Universities, NGOs, and government organizations, all this is happening as far as satellites are concerned. Driver of scientific and technical development, but also expanding scope for existing capability. It increases. Does not always require a dedicated launch. Please come. Yeah. So no universal definition, but it is being generally divided based upon the weight. Like mini is about 100 to 500, micro is 10 to 100, nano is 1 to 10, and pico is 0.1 to 1 kg, and femto is about less than 100 grams. There are some regulatory issues as far as these small satellites are concerned. I think we have to pay attention. No existing dedicated rules, specific international law, but a general compliance with existing regulatory requirements. That also is a question mark. It is not that people are following it. There are hard laws, there are soft laws, there are no, not designated with small satellites in mind. Nothing has been actually kept with these items in mind. No national legal framework procedures. Are states doing enough? We have to ask this question. I do not know what, even in India, when the small satellites are being doing, other than what the Space Department is able to do, in which orbit and where it will go, other than that, I think there is not much. Understanding expertise regarding peculiarities of small satellites is a question mark. These are all new to the space activities, so regulations are not known to them. Small satellite program predating national law. Who is authorizing and what is the supervision of such things? These are questions which needs to be answered when we drive the policy for the space satellite, new satellites. I'll now touch upon some of the new technologies which are emerging as far as the future space missions are concerned. Antimatter powered rockets. Now antimatter is lighter than the general matter, and hence this is another area which is, but only problem is to create antimatter, it's a major issue. But certainly it is going to happen one day or the other. Future space technology will be laser and microwave powered rockets, in which an alternative propulsion method could be the beam laser or microwave energy at the rocket from stations on the Earth. And this would heat up the propellants on board to great temperatures, and it will be possible to propel at that point in time. Similarly, future space technology, that will be sun-powered rockets. Similar system in which sun gives out the energy for free, and a new way of harnessing this energy in space could propel a spacecraft for the future. According to this concept called solar thermal propulsion, mirrors or lenses would focus sunlight to heat methane or other propellant. The hot gas would then propel the vehicle forward. These are some of the things which are happening. And the application perspective, already we are talking of, we just saw the heaviest vehicle lifting off just about 2 weeks back. So heavy lift reusable launch vehicles, then space manufacturing, solar power satellite, in which the solar, as I mentioned by Dr. Kalam's vision, that we should be able to collect solar power in the space and beam it down. Solar powered satellite demonstrators and illuminators, space colonization, reusable low cost launchers are all on mass mission, thousands of tons per year. That is the kind of applications which are going to emerge in the future. This is the view of a space solar power, in which there is a collector, there's a collector there, and then from the collector you have either through the laser beams or through the microwave, you beam it down, and then you have receiving stations which will convert this back into electric power, and hence it can be then distributed. You also discussed about militarization of space. That's why I said there could be a bit of repetition. So space weaponization is taking place. It's a reality, whether you like it or not. There are asset capabilities developed. There are people who are in a position to make killer satellites, micro satellite, position in vicinity of the target satellites, destruction mechanisms like kinetic kill or electronic EMP or the spatial warheads, they can be used. High technology areas which require for this kind of a mission as accuracy of positioning of satellite, and ability to control satellite path very precisely, and activation on command whenever you want. So there is a kind of a sleeper satellite which is available, and it can be activated and triggered at any point in time. There are space-based weapons, space to space, space to ground, directed energy, high energy weapons which are laser weapons or microwave weapons. Space C4I and space surveillance systems like radars, point-to-point communication, intelligence gathering, and space assets database, which is again, and of course there are potential denial mechanisms like dazzling or blinding the satellites through the lasers or microwaves. These are various activities which are developed technologies today. Only it's a question of people are not accepting that they are being used or not used. We do not know who is using and who is going to acknowledge it tomorrow. The time only will tell. There are vulnerabilities of the satellites, electronic warfare, physical attacks on the satellite ground stations, dazzling or blinding, I mentioned already, of the satellite sensors. Then you have radio frequency weapons like HPMs, hit-to-kill ground-based lesser anti-satellite weapons, pellet cloud attacks on the low orbit satellites, attack on space by microsatellites, hit-to-kill satellite weapons, and high-altitude nuclear detonation. These are all some of the vulnerabilities which are there. So a country like that, what it should do? If it is, like what Colonel Singh was telling, if my infantry is going to depend on the navigation or the communication, which is supported by the space navigation, space segment, and if it is denied, what I should do? I should have the capability to rebuild space systems in the wake of space negation and could reduce vulnerability. In that case, this should also include capability to quickly rebuild the ground stations. You should be able to do it in less than 24 hours. What does it mean? That means our capacity, what we call as a launch on demand. I should be able to launch within 24 hours at least a low Earth orbit satellite weighing about 100 kg to 150 kg. And it could be either surface launch, it could be air launched, what kind of capability. These are the capabilities one has to be prepared for. Launch ready spacecraft. You can't wait for the satellite to be integrated. It should be launch ready, whether it's with the EW payload, or it is with communication payload, or it is with navigation payload. It should be available to you. Then develop low cost quick reaction launch vehicle and microsatellites for different payloads. This capability should be available if you are using space in a big way for military purpose. Now I'm going to talk to you about new space age. What is happening? This new space age is like this came in Washington Post. Old space is slow, bureaucratic, government directed, and completely top down. We have also seen this happening in our country. Old space is NASA, cautious and halting, supervising every project down to the last $1,000 widget. Old space is Boeing, Lockheed, and Northrop Grumman. Old space coasts on the glory of the Apollo era and is not entirely sure what to do next. New space is the opposite of all that. It is wild. It is commercial, bootstrapping, imaginative, right up to the point of being delusional. So that is what the Washington Post published. So what is new space? It is disruptive, sectorial, dynamic, featuring various end-to-end efficiency-driven concepts driving the space sector towards a more business and service-oriented step, in which substantial private investment will be involved, innovative public schemes will be involved, new entrants will be there, new industry verticals and space markets will be there, disruptive market solutions will be used both in terms of business as well as in terms of technology, innovative industrial approaches will be used. It cannot be same cottage industry what we have been seeing as far as the integration and assembly of satellites and launch vehicles are concerned. It is only by the scientists who used to do the work even till today. Now that I think is going to take a different change, and in that innovation industrial approach is what is happening. New space actors implement new industrial methods as part of their innovative business models. Industrial organizations optimization, they are trying to do supply chain rationalization, they are doing vertical integration, they are also reusing the proven technologies. For example, what you see in the SpaceX is nothing but using the available technologies in a big way again and again. Economies of scale they are talking of. Once upon a time, we never bothered about what will be the cost of launch vehicle or the satellite, so long as it was serving the purpose. Gone are the days. As I was mentioning to you, if $40,000 per kg is the cost of launching, then nobody is going to afford it. It is a competitive world today. So we have to look at the economies of scale. Automation and digitization is also finding a major place. So the main driver is cost effectiveness as far as the new industrial approach is concerned. And there are disruptive market solutions in the new space age which is coming. Focus on solutions with the capacity to disrupt existing markets or address new markets with specific value propositions like low prices, like integrated solutions. It cannot be just disjointed, and also adapted solutions from one area. What is happening in automobile sector, I will take into the space sector and vice versa. These solutions are not necessarily based on new technologies, but rather on revisited concepts, giving way to alternative innovative dynamics. Private investment is increasing considerably, and in an average nearly 1.5 billion was invested annually in, this is a US figure, startups during the period 2010 to 2015. So you can see how much of the private investment is coming in this area. It is an opportunity and a challenge. It offers an opportunity for governments to leverage more ambitious partnerships with private business. It reduces risk and cost sharing takes place. It will also have industrial organizations which can be on optimization basis and socio-economic impacts maximization. Certainly it will have, even today we are seeing more and more space components and devices today are now going into the private sector, even from the Department of Space or Defense and things like that. This has got an impact in some terms of employment, Make in India, and variety of other positives. The emergence of new private actors with aggressive strategies is a competitive challenge to be taken. And there will be, of course, competition. The moment more and more private sector comes in, there is going to be competition. And I don't want to see a day, which has happened in the case of PSUs, that once the private sector comes, people say, do more and more disinvestment of PSUs. I hope this day doesn't come, that we have to disinvest our Department of Space. Sorry, I hope it doesn't happen. But it's important that we have to have a policy framework when the new space age is coming. And basically this policy framework has to be coherent, and this coherence is around innovation and the growth strategy, in which is a space growth partnership. This is what we need. In terms of national space policy, which will be based upon enduring principles, roles and responsibilities, civil space strategy to secure a prosperous nation, and national space security policy for civil-military coherence. All these three edges of the triangle, they have to be coherently available as far as the policy is concerned. Next, please. Now let's look at what is happening to enhancing G2G dialogue and cooperation. All major spacefaring nations value the importance of an explicit space policy to optimize benefits and ensure clarity in goals and intentions, both internally and internationally. Basically, if you have, then your vision is very clear. A declared space policy is highly valuable from an international perspective because it can serve as a communication tool to affirm principles and boundaries and avoid speculations. You will understand when I say avoid speculations. One could be saying, oh, they are giving a garb of only doing the peaceful space utilization, but they may be actually developing the military space and so on. If you are doing something, you should be very transparent on that. Space policy is per se an invaluable transparency and confidence building measure, TCBM as we call it. Articulating a space policy would enhance India's standing as space power and partner in international rulemaking based on shared national interests. And knowing India's interests, needs, and priorities help foreign partners to better frame the scope of cooperation in terms of data and information exchange, policy dialogue, and joint activities in areas of mutual interest. So this is I personally believe that just certainly space policy enhancing should be done. Now, what should be the goals of such policy? Its policy goals should be energize competitive domestic industries to participate in global markets and advance the development of satellites, manufacturing, satellite-based services, and so on. Expand international cooperation on mutually beneficial space activities to broaden and extend the benefits of space. Further, the peaceful use of space, that should be done. And strengthen stability in space through domestic and international measures to promote safe and responsible operations in space, improved information collection and sharing of the space object collision avoidance, production of the critical space systems and supporting infrastructures, with special attention to the critical interdependence of space and information systems. That should be the third goal. Fourth is increased assurance and resilience of mission essential functions enabled by commercial, civil, scientific, and national security spacecraft and supporting infrastructure against what kind of disruptions can take place, degradation can take place, destruction can take place, whether from environment or mechanical, electrical, or those could be hostile causes. It could be from any one of them. So pursue human and robotic initiatives to develop innovative technologies, foster new industries, strengthen international partnerships. These are all basically to explore the solar systems and the universe beyond. Improve space-based Earth and solar observation capabilities needed to conduct science, forecast terrestrial and near-Earth space weather, monitor climate and global change, manage natural resources, and support disaster response and recovery. This should be another portion of this. Then space governance policy, we should look at some of the facets of that. A domain that for a long time remained the monopoly of 2 or 3 big powers. Outer space is today a crowded space, congested and contested territory with more than 60 players, including non-state actors. From the decades of intense competition between US and USSR, outer space has come to be dominated by peaceful and civilian users. Driven by a combination of factors, including the growing space-based applications for social, developmental, and security-driven utilities, as well as changing global balance of power dynamics, the long-term stability of outer space seems threatened. So contrary to popular perception, outer space is limited commodity, and it is responsibility of every state to ensure that the activities are peaceful. Secure and uninterrupted access to outer space had already been challenged and by the spiraling competition witnessed in the earlier decades. We have been fighting for orbits, we have been fighting for a variety of operations, and people are keeping track of, people are leaving debris. All this is becoming a major issue, and we are not finding any solutions thereof. So space governance should cover all of them. Unless corrective steps are taken to address the growing number of challenges, including space debris, spectrum allocation, and radio frequency interference, access to space in future, especially for the emerging actors, will only prove to be more precarious. So these are all have to be part of the governance policy. In rhetoric, all the spacefaring powers endorse the need to keep outer space safe, secure and sustainable in the real world. But the gaps are yawning. Even today the gaps are yawning. You have this problem. There are rapidly advancing military space programs, including anti-satellite capabilities. I mentioned to you some of them, which are inherently destabilizing, and increasing space debris as well as the proliferation of small satellites, including mini, micro, pico, and all that, will lead to congestion in the outer space. All we have to cater for that. Each of these needs to be addressed in priority manner if there is to be uninterrupted and secure access to outer space for the future generations. Now, who will do this? We have one agency called UN Corpus, and its goals are limited nature of the space resources will require some governance. So UN Committee, the highest international forum for political, scientific, technical, and legal debates connected with space. We are aware of that. It is the exclusive platform in the area of peaceful uses of outer space for negotiations, elaborations, promotion of important international treaties, agreements, UN resolutions, and guidelines for all members. Year before last, when I came for this conference, we discussed this. And I mentioned that even in this umbrella, there are nations like European Space Agency which wants to have a policy. There's a US who has started doing something independently, and then they said they made a committee of nations, about 15, in which Sri Lanka and others were there, and India was not part of it. Now, in a situation like that, but we have to still resort to this UN agency. So UN agency and its subcommittees can serve as a unique platform at the global level for international cooperation in space research and long-term space utilization in the interest of global development. So there was this particular conference on exploration of peaceful use of space, what is called the Unispace 1, was held in Vienna in 1968. It is going to complete now 50 years. So Unispace plus 50 has been now configured with the following objectives: global partnership in space exploration and innovation, legal regime of outer space and global space governance, current and future perspectives, enhanced information exchange on spatial objects and events, international framework for space weather services, strengthened space cooperation for global health, and international cooperation towards low emission and resilient societies. And finally, the capacity building for the 21st century. Rajeswari was already talking about transponders not having enough capacity. We are not having enough capacity for meeting the communication requirements, the television requirements, information exchange, data rates. Obviously, capacity for 21st century demands are going to be very high. So we have to start looking at that. So government policy approach, what should India's approach should be in all this? Government of India needs to take such steps in building up such an extensive ecosystem to engender a space 2.0. Like we have industry 4.0, the equivalent of that is industry space 2.0. And there is 3.0 already emerging now, space 3.0. Such a vision should enable the industry to not just support the needs of the local market, but to take up the turnkey development upstream and downstream products and services for global marketplace as well. So it is just not for within, it has to be globally. This path is in retrospect to the current, can create a multiplier effect with some substantial benefits, which are some of them are creation of new jobs in the highly skilled labor market, in the private space industry, reverse brain drain from the country and boosting Make in India, which is our requirement, avoidance of taxpayer money circulation within the ecosystem, in favor of the foreign customers procuring turnkey products and services, adding on edge to Indian foreign policy drivers, with space as a major emerging tool in fostering relationships. Space can be actually a very, very good binding force in all our diplomatic parlance, enabling space technology to be used as a tool in the defense of the country and allowing the armed forces to engage with the private space industry in creating a strong local ecosystem for indigenous procurement of defense products. Now there is building further focus and uninterrupted future national capability in space, which is absolutely essential. The nation needs to be assured that space systems that best respond to national needs are made available all the time, and that gaps in services do not get created, as has been witnessed in satellite transponder capabilities. We just again came to the same point. Or high resolution imageries. I still remember when Kargil took place, we were getting all our images from outside countries. I remember that, because we were not in a position to get the same images what we needed, what was happening in our own country. Today that situation is entirely different. So a pragmatic long-term planning of Indian space is required, with a visionary partitioning of roles for different segments in the national ecosystem. Space will also be developed as a vital tool for national security interests and safeguarding Indian national interest. Building a combinative ISRO and industry capacity is critical for future space success. We need to have a very strong partnership, especially in areas of operational satellites for communications, remote sensing, security, positioning, disaster management requirements. The concept of the industry building, owning, and operating space systems must be positioned. It cannot be purely a contractor relationship what we have today between the industry and the research organizations. It has to be one of evolving design from the industrial sector, and that capability has to be really achieved. If that happens, then there will be partnership, and then there will be another SpaceX coming from the Indian industry. That is the kind of thing we are looking at. It will be advantageous to expand space capacity in the nation and enable to space ecosystem into private sector space in India, and enable a competitive national space capacity of ISRO and industries to emerge. That is what is needed. Advancement in the state of the art in space technology and adopting a leapfrogging approach are essential. This would require careful and judicious flexibility to buy or build approach for critical gap areas, assimilate and source partner for newer technology systems, parallel approaches of source and develop for critical dependency systems. Such an approach is most critical if one has to maintain the excellence and also be equal and compete in the global systems. So, new space policy for India. In this, space has triggered many new services and products applications which reach out all over the country and deep into society at multiple levels, administratively and judiciously. Newer institutional frameworks are called for downstream national level applications and delivery systems. In an end-to-end concept, national space agencies must not carry the burden to undertake large national level societal applications. Now, this is one important point which is emerging out of this. Now, today there is a Department of Space which not only does the space research and does the launching and satellites and everything, but it is also worried about how to take the application to agriculture sector, how to make it available to the geological sector and things like that. There has to be a different approach to carry the burden to undertake large national level societal applications that emanate from administrative and governance demand. Space must be an instrument to spawn newer and larger structure organizations for application and usage. That is what it should evolve. It should get into newer organizations to take all this aspect. Intensifying a two-way international cooperation is an essential step. On one side, to embark on major exploratory programs through synergy of partnership and assimilating technology and experiences from other nations, and on the other side, for bringing Indian capability in the goal markets of space. That's what should happen. This combined approach must be intensified by active participation in multilateral space frameworks and selective bilateral space cooperation, especially in future human space flights and planetary exploration system. I think there should be a tremendous collaboration which should happen in these areas. Build a comprehensive space governance system that brings into focus the governance of space activities within national system and in agreed alignment with international space governance regimes. This is what is needed. So India's approach, as India picks up space, its approach to collective governance of global commons has also begun to change. Slowly it is happening. India has shared its past apprehensions for a more proactive approach wherein it looks to play the role of an active party shaping the debate along with other major spacefaring powers. India began to undertake this gradual shift in the face of more direct threats in the form of growing missiles and anti-satellite weapons in its own neighborhood. The logic is quite clear. India has made significant investments today in the outer space domain, and thus there is a material stake in the kind of rules that are being written. I was very sarcastic and critical last time because we were not part of the way the rules are being written today. But I think slowly it is changing. Also, India's desire to be part of the global governance mechanism as a solution provider and norm shaper has driven India in this direction. The national security-driven approach, as against the moralistic drive, is far more sustainable both within the country as well as in the global governance circles. Given the current state of play in the outer space domain, India should make efforts to develop all measures, treaties, TCBMs, norms of responsible behavior, and code of conduct while recognizing global differences and respecting global space powers. Now I have a couple of recommendations which I think came up some time back. I am just trying to recap some of them. A facilitating foundation. To be able to even debate commercial space in India and their viability within the government, or to make specific recommendations to the government, there needs to be a facilitating foundation. Today, this process is done by the Department of Space. It is more important that this foundation remain without any conflict of interest to make recommendations to the Government of India, with no particular dedicated independent space commerce assessment body for space-related activities, or a dedicated roadmap within ISRO for commercial space in India. There is a need to establish an Office of Space Commerce that is independent of ISRO. That is the recommendation. Demarcating space and defense. Issues around national security will always be a concern when an actor chooses to pursue space activities. However, holding possible commercial possibilities in utilizing outer space hostage under the garb of national security will only hold back the country in expanding products and services. A conflict will always be a problem, so we have to find solution to that. This may also lead to an ecosystem of Indian space entrepreneurs creating holding companies in space commerce friendly countries and other operating their product service, eventually creating loss of high technology jobs and tax revenues for the country. This also has to be safeguarded. If you are going to have a large number of friendly countries coming in, or you are taking services from outside, there is an impact on the job, there is an impact on the industry. Like it is happening in other sectors, it should not happen here also. Several scenarios of commercial space activities have played out in leading spacefaring nations. There already lies a template in steps taken by governments in securing national security while actively promoting space commerce. Now, how the other countries are doing? We have to also do a similar exercise. We can't say that we have a firewall now, so we will not look at what the military wants and what the space can do for peaceful purpose. There has to be a certain amount of amalgamation, but with certain clarity. And that clarity should be part of your space policy. And once that is happening, I think we should be in a position to play the role in a more effective manner. These can provide significant lessons to the Department of Space in formulating an active commercial space strategy for promotion of Indian space industry. Next. We should promote startups. The way IT sector has really thrown up startups today, I think if an Indian industry needs to claim a greater traction in the international space market, there is a need to promote and develop a model for promotion of startups with independent technology-based ideas which carry the potential of leapfrogging product services offering out of India and are scalable globally and bringing potential investors and stakeholders on the same table to promote innovation. Space laws. The enhancement of the space legislations to define regulatory, legal and procedural regimes with transparent timelines for pursuing space activities by private space industries currently in nascent stage. We don't have any major regulatory mechanism. No national laws govern space activities while remaining critically necessary. Many times we give the garb of secrecy and say, no, you can't do satellite because it is a strategic activity, it cannot be given to you. Activating standalone policy packages for regulating a service product as a retrospective measure on commercial interest can only be initial step onto actively promoting and encouraging commercial space activities. Manufacturing for the space sector. While there has been a tremendous collaboration between industry and Department of Space, but still the government has taken significant steps in creation of an active investor mindset by rolling out programs like Make in India. But even though space has been identified as a sector within the campaign, no significant proposals have been mooted for manufacturing space-related systems in India. There's not even a single major industry that can say, look, this is the kind of evolution has taken place. So there's a need for a transparent strategy on how the potential of the space sector can be leveraged under this program. Otherwise, Make in India will be only without space, without defense, and so on. There are significant opportunities in manufacturing, for example, small satellites and services like the GIS systems for which a framework for engagement needs to be developed. We should also have a think tank and more academia interaction. Today, the academia interaction is basically on a problem-solving basis. If the Department of Space wants a problem to be solved by IIT, a simulation or some kind of analysis to be done, or a little bit of fundamental research to be done in some areas, they go to them and that kind of a relation. I think it has to be much more than that. If there is a scope to establish an independent, wholly space activities focused think tank, similar to the European Space Policy Institute. Just an example, it could be anything different. Constituting distinguished expert in the space field while preserving its independence in the preparation of its various research outputs, research materials, and expert gatherings. Such a think tank will not only provide a fair assessment of national goals, but also potentially key insights on space program management, dual use of technologies, economic impacts of the space expenditures, space law, international cooperative space agreements, etc. To sum up, with this all can be done, what we are doing. Space has become a normal contributor to our everyday lives. We are aware of that. Space services are already delivering growth and have great future potential. We must exploit the opportunities, mitigate the threats. That's the word we have to see. Exploit the opportunities and mitigate the threats. Key orbits are congested, axis is contested. The strategy and regulatory actions to assure access to orbital and spectrum resource and to prevent the buildup of space debris. Work with international partners to monitor the space environment. I think this is a major requirement. Protecting space systems against natural and man-made hazards. Security and resilience planning we have to do. And undertaking resilience assessments and promoting mitigation plans and promoting R&D to build resilience and improve awareness. These are some of the things I thought we could start taking, and this platform should certainly push them forward as a policy, as a first step towards improving the entire framework of the space research and development and manufacturing in the country is concerned. Thank you very much, friends.
Thank you, Dr. Saraswat, for an extremely rich and detailed presentation. Will you take a couple of questions? Absolutely.
Whatever I can.
Okay, so you have had. So we now open up the floor for a couple of questions before the wrap. Yeah, absolutely. Victoria.
Hello, Dr. Saraswat. I'm Victoria Sampson. I'm with the Secure World Foundation, and I got a lot out of your presentation. One thing I wanted to ask you about is the U.S. military considers space to be a key enabler for carrying out the national security mission. I'm wondering if you see the Indian military changing its thinking or starting to consider that, and if so, what would that look like?
See, utilization of space for civil has been our major focus. But it doesn't mean that India will not use the space for the military purpose. But our space utilization is for the defensive activities of the military space. That is, we would like to use it for navigation, for communication, we would like to use it for surveillance and things like that. Our intention is not for creating space warfare. Our intention is not to attack the space assets of different nations and things like that. But certainly space as a military aid is one of the segments which we will be working on, we are working on, and we would like to continue working on that.
More questions on the floor? Daniel.
Thank you, sir. Daniel Porras from the UN Institute for Disarmament Research. My question for you is, do you see India's role evolving at all at the international level in terms of the development of norms for responsible behavior, perhaps seeing India as a leader in establishing these kinds of norms?
Yes, India with a population 1.2 billion, which is so whatever is that percentage. So we are a nation, if our voice is not heard in the Committee of Nations in the planning for the responsible use of space, the loser is going to be the world community. I think it is essential that in whatever platform we plan the space policies, the international laws for space, for the responsible use of space, for civil usage and all the activities which are beneficial for the mankind, I think India has to play a major role. And unfortunately, as I was mentioning in my talk, when US formed or UN formed, I don't know which, I think UN formed the subcommittee looking at the space policies. At that time, we had countries like Sri Lanka as one of the partners, and India was left out. Now, such misgivings should always be taken care of by the international community, because you can't ignore a population of 1.2 billion people. And that too with the advancement of India in the space technology segment is so high that we are competitive today. We are competing in every segment, whether it is satellite launching or satellites or space missions or deep space missions. So India is globally competitive today. So his voice has to be heard.
Thank you. Kasuto there.
Very much, Kazuto Suzuki from Hokkaido University, Japan. You mentioned about the think tank, creating a think tank and something like a European Space Policy Agency, Institute, which I think Marcus can answer some questions. But how do you see the role of the intellectuals and those think tanks, and what do you expect for the sort of a non-space people, I mean, like us? I mean, I think many of us are coming as an outsider of the space community in a narrow sense, but we are the ones who think about the strategies and policies. So what do you expect for those think tanks?
See, there are various elements of the space, One is technology. Another is the regulation and policy. Third one is application. Fourth one is the commercial aspect of the space in terms of the economics, the socio-economic impact of the space. Now, I consider these segments are multidisciplinary. So it's not only that the people who are deeply involved in the technologies of space only can do this kind of work. People who are intellectually poised to take on any of these elements, they can be part of this think tank. The collaboration with the space agencies which are actively involved in this will be in the form of research and development on various topics of these segments. Think tank in terms of looking at these activities as a standalone measure. Sometimes what happens when you are completely engrossed in this, your views become biased. And as a result, you don't come up with the real solutions which are unbiased solutions, which will be actually beneficial for the mankind. So a completely standalone view should be emerging from such think tanks. And hence, this exercise of having a think tank which can debate on technologies, debate on policies, regulations, legislation, socio-economic impacts, commercialization, I think will be a good solution. And in that, anybody could be partnering who has got the capability to think on these subjects.
Thank you. Are there any more questions? Sir, will you like to make some concluding remarks, sir? Absolutely, sir. Absolutely.
Good evening. After that brilliant address by Dr. Saraswat, there's not much that remains to be said. He wrapped up a lot of the points that had been discussed. And especially for a person like me, whose knowledge of space basically derives from Star Trek. There is not much that I will be able to add to it, except one simple fact from my viewings of Star Trek. The one lesson you learn is that when you start moving at warp speed, your spaceships have to be built of some very different materials. The materials with which you build your traditional spacecraft no longer hold. That also holds true for organizations, institutions, governments, as they move into a new technological revolution. And this is what we are witnessing before our very eyes. So what we are going to be seeing is a complete transformation of how we try to imagine our institutions. Imagine the culture of regulators. Imagine the culture of government itself. Because current kind of structures, what we are finding across, will not hold together. And countries which will not innovate in structural changes will tend to get left behind. The ones who innovate in those structural changes are the ones who are going to rapidly steal a march over everybody else. And that is a challenge which all of us face. So much of innovation is not actually about path-breaking new discoveries. So much of innovation is just many times about getting 1 and 1 together and making it not 2, but 11. But to do that, there is an ecosystem which needs to be created. That cannot happen without an ecosystem. And examples abound of this kind of, we can give hundreds of examples of this. For example, even what happened in 2008, which completely changed the energy markets, the shale revolution. Technologies for shale revolution existed for 50 years. Some existed for 50 years, some existed for 20 years. They were all there, they were all available. But something happened which removed the risk in getting those technologies together. And when that happened, suddenly it took off. And it took off only in one country. Other countries with shale resources are still to catch up. They haven't yet started. So there is a lot about how we can create these kinds of systems where innovation finds root, takes place. And as the Observer Research Foundation, our effort is to think in terms of these creative ecosystems, how they can be created, how systems can be nudged. Because organizations have a way of perpetuating themselves. Organizations have a way of fighting for their turfs very, very diligently. But you're moving into an era where so much of work is going to be done across organizations. And collaborations between individuals across organizations today is becoming far more important than what is happening within organizations. The future of even corporations is going to look very different. Forget governments. The corporation of tomorrow, the company of tomorrow is going to be very different from what we are seeing today. And this ability to be able to do cross-cultural, cross-organizational, collaborative work is what is going to be making the difference in the future. So that is a challenge for all of us. It is not just a challenge in India. That is actually a challenge which is being faced globally across the world. And some are going to win in this, some are going to lose in this. Let us make sure we are the ones who win. Thank you.